Good morning, everyone. Thank you for being here today at our session on labeling data for machine learning purposes. In order not to mess with GoToMeeting, I had a bit of introductory material just to try to get us all on the same page, and I'm just going to talk about it a little bit. What I wanted to say is labeling is a classification problem. It's the problem of identifying to which of a set of categories or features a new observation belongs. And it's a type of supervised learning, and probably no one in the room needs this, but I just wanted to say that the steps in doing supervised learning is to identify a set of samples from the data space and tag them with one or more labels or categories, and then train your model or algorithm, and then one provides the new unlabeled data to the model for it to predict the category. So it's that simple. Labeling, however, is a bottleneck. It's difficult to automate. It often requires humans. Many samples may be needed, and minimizing the amount of samples needed is a hard problem and requires expertise. I learned recently that ImageNet, which is the largest labeled data set available to the public, and it's used in computer vision, has 14 million images. It has 22,000 visual categories. It started with labels generated automatically from captions and tags, so they had a bit of a lift in from something automated, and it took 50,000 paid workers looking at 160 million images. So an interesting scope data point. So this need is holding AI back, but tools and services are being developed. So today our presenters are, in this order, Rahul Ramachandran, excuse me, who is presenting the image labeler, Jihung Sun, who is presenting label IMG, and then Jim Bednar, who is presenting bokeh. Just a word about following up. We will have a hands-on workshop in the session following this session where we can take interested parties through label image, and also bokeh. Jim has worked hard to make a nice bokeh demo, hands-on demo for us. And then people are interested in the labeling problem, so I hear regularly, and we already have some possible labeling demos and workshops on deck for the summer meeting. So we'll continue to pursue this somewhat with that. Arif has talked to me about some mathematical approaches to labeling that he has taken. Rahul may be able to actually give a workshop for the image labeler that he's presenting today. And then Yuhan, I was thinking of your friend and colleague Katie, who has a mobile-based experience with a mobile-based app, apparently. So without further ado, I give you Rahul Ramachandran.
So I think I'm going to talk about the image labeler, which has been rather creatively named. But I'm not the right person because it's developed by my machine learning team. So I'll give you the overview of it. And clearly, most people here are computer scientists and not domain scientists who would be labeling the data.
This big presentation. Yeah. Good. That's good. Thanks. Oh, thanks.
So I've some slides and then basically movies that show the functionality of the tool. I think Anne mentioned this. With the nerd science, we really lack benchmark data sets
Just
that
stop
can
a
be.
little bit because the screen sharing is not correct on the GoToMeeting.
Doing and out.
It's not something.
See if you get out of it.
Yeah. Now it's back.
Okay. So we know that there are limited training data sets. One of the key issues that we are facing, especially for applying machine learning effectively with earth science, and the other major issue is the data heterogeneity that, I don't think that too much can be done. That's the nature of the domain that we are in. But the training data, definitely there are things that we can actually do. And how do I go forward? Okay, yeah. I showed this yesterday. This is last 10 years trend in literature within earth science, looking at papers at AGU, AMS, IEEE, NSPIE, and you see a remarkable increase in machine learning algorithms being used as part of scientific analysis. So clearly there's a trend where machine learning libraries are being used the research community is getting really familiar in using these algorithms as they're using statistical packages. One of the interesting things, we did a deep dive in 1 year's worth of AGU papers to just look at the kind of training data, the number of samples that they've used for supervised classification, about 700 papers. The distribution, you can see it's, tends to be on the lower end. And this is an issue for us if you're looking at deep learning, right? You talked about millions of images. That's what you need to train a data robustly. So takeaway here is we need tools, methods, and sharing of these training data to actually allow scaling up of these machine learning algorithms. So, so there are three generic approaches to build training data. I think the one that we're talking about today is focused on manual ways of, bootstrapping the machine learning process by manually tagging data sets or creating the labels. The other approaches are like programmatic or algorithmic approaches where you can use data programming tools like Snorkel, data augmentation techniques, GANs to create synthetic training data. The third approach, I think that ESIP community, I think, could really help is this whole data and information curation approach, because you can use different sources as labels for another data source based on resolution, sensor type. There's obviously crowdsourced approach is another way. Datafication idea is that there are information sources, not data, that you can use to identify and create labels like event information that are embedded in different websites that you can scrape and pull out. So if you are clever, you can scale out some of these approaches to create training data. So the driver for building this image labeler was we were working on trying to create phenomena detection in satellite imagery. specifically on the NASA browse imagery that is available through Gibbs. So we wanted a labeling tool that integrates with our data system. So it integrates with the Gibbs backend. You can just go start looking at different Gibbs layers, and you can start tagging and creating the labels. And you allow sharing with other people so that you can do it as a team, because it will allow you to scale up at least the bootstrapping part as best as you can, with the goal of building an event database. So you save the information independent of the image, because then you can use that information on multiple data sets, right? If you have the information, then you can, something that may work for Modis may also work with SAR or some other data. And it'd be nice if we, obviously with the labeler, we want to enforce a uniform structure, data structure metadata, so that the training data, the machine learning workflows can use this. I'm giving up on this.
Okay. Let's try one more time.
Yeah. See, it works. It's okay. So it's a cloud-based tool. The idea is that science teams can go label data, create shapefiles, or put bounding boxes on the imagery, and then the metadata is stored in a database. Then it can then work in a pipeline that you can access it with your machine learning algorithms automatically. Let me see. This is the URL. If you're gonna go play with it, and I'll just run some movies here to just show some of the functionality. I'm afraid I'm gonna break everything, but so this is what the tool looks like. You can select the Gibbs extractor, so it connects with the Gibbs server, where you can select the different layers that are there within Gibbs. So you can select the sensor, the specific product type, and then create a bounding box of the region that you're interested in, and then bring it into your event folder. So this is the example that it's showing that. The other nice feature is if you know climatology of a particular phenomena, so for example, high latitude dust that we're looking at occurs frequently over Iceland, you can actually focus on that area itself and just get those images. So you can get a lot of samples really quickly using some of the climatology information. Time save, yeah. So this is showing that those images, and this is a test event, is tagged as test. It's basically brought in. So this first example is you have, you're just doing present or non-present of a particular phenomenon in an image, right? It's just and then the tagging bit is fairly straightforward. You just move it. You just apply a tag by selecting a whole bunch of different images. So you select whichever image you want to say your phenomena is present in it or not, and you can just it tags it automatically. Yeah, you can. You can just drag along. Yeah. So you can do bulk tagging, right? So that's the idea, that you can do bulk tagging. You can also upload test images. It doesn't have to be the case that you are, connect using the Gibbs at the back end. If you have specific images you want to upload, you can do that. So let's see what else is here that is of interest. Oh yeah, and then obviously there's the metadata, all the tags that you create is saved. This is for browse images and geotiffs right now. Yeah.
If you wanted to look at a lot of, if you wanted to look at a lot of spectral channels independently of each other from Modus, that's not supported yet.
No, so this is anything that's on Gibbs. It'll actually. I don't know whether the data that you're looking at it has a Gibbs imagery or not. Certain bands are used to create Gibbs products. Yeah. So the example was, the example I showed was where you're looking at a particular image and saying whether the phenomena is present or not. This is going a little bit deeper, that you take an image and you're now looking within the image certain areas that you want to tag, right? You want to have bounding boxes. So dust is a really good example. You want to identify regions of dust so that you can do pixel-based classification rather than image-based classification. So you're identifying areas where you say that these areas, the pixels have a presence of dust or not. So somebody cannot priority define the categories. No, you can create. That's you. Oh.
My question was, have people priority defined categories?
No, you can define the whatever event type is of interest to you. Yeah. So the list it's showing is what we are working on actually. And then it saves that information in terms of the context to that image and the location in it. This is the team-based collaboration, which is kind of a nice feature. We tend to use grad students a lot. So we can collect images, especially if we select a bounding area over a certain region where we know based on climatology that event occurs. And then we can grab those images and then distribute it to a team. So we can create a team of people who can tag. And that works fairly well for us. So I think this is a video that's showing that you add a team member and then you distribute the labeled, the different images to them. So yeah, all the grad students are there. All right. So I'm sure there's more to it here than I can explain, but yeah, so it's like showing it's distributed to different team members. Let me go to the last one. So we got, we work with the scientists at NASA Marshall Sport is a project that we work with quite a bit. They made a request for this tool to work with SAR data. So they wanted the ability to upload geotiffs and shapefiles. So this is the new thing that was added, that you can actually upload geotiff imagery and then also upload shapefiles or save as shapefiles. So you can kind of work with GIS packages if you needed to. So this is the feature that shows that bit. So then you can modify shapes as needed. So primarily it was designed for our team based on what we were working with, but I think it is possibly reusable, especially if you are interested in utilizing the Gibbs layers that are there. And it's on the cloud, and we can actually allow anyone to make accounts. I do have one last slide. If you're going to go this route of doing workshop on labeling, I think the last bullet is something I would make a request that, when we do this, let's make sure that we are sharing the training data with others in some form or fashion. And also the models, especially if you start building really deep networks so that others can leverage that model. And best practices, we need to figure out a way to standardize how we create these training samples so that the code, the machine learning code, there's a uniformity in how we access the training data and utilize it. So since we are starting off on this effort, it'd be nice that if we could kind of work on these issues too. So that's my last slide. Thank you.
Do you see expanding this tool so the base of images that can be analyzed could be from a non-official NASA holding? Suppose someone's working on generating a data set, wants to label it prior to making it an official holding.
Yeah, I don't see why not. If there's a standard interface, I think I know it can connect to any OGC interface at the back end. Yeah.
It's not baked in hard.
No, it's not. Yeah, it's standard based. So if you have some server that's serving the data using some OGC standard, then it can connect to it. Yeah.
It's unclear from the website if this is open source and if there's a GitHub repo for it.
I don't know whether it's gone through I don't know where the status is. Everything that we do is open source.
Right.
Yeah. So whether it's gone through the NASA bureaucratic process, I don't know where it is. I can double check and give that.
So,
And we can give you access to the GitHub.
Okay.
We have no issues with that. But
and then maybe more of a general question: is labeling always done by rectangular bounding boxes, or is within machine learning is it work to have irregular shaped, like just lassoing some irregular shape? There's no restriction in.
so I can give you based on the application. In some cases, we are looking at just presence or not presence within an image. But for example, we're looking at smoke and dust, which are irregular shape. You have to find where the extent is. So.
Thank you, Rahul. And next we have Jihan with label image.
So just one, there's an online question for Rahul about, have you published your label somewhere?
The labels, just the labels? No, not yet. We don't know where the labels would go, but it's available on the cloud on an S3 bucket. Yeah. If they want access to it, it can be given.
Okay. I think I'm Ziheng Sun from George Mason, and my talk is gonna be I want to review the state of art labeling tool. Most of them are open source for object detection using the deep learning and machine learning. So so we are first we should understand how many labels we really needed. So here I want to introduce the concept of label augmentation, which means manual labeled allocations could be augmented into maybe hundreds of thousands of labels by program. So it means it's not necessarily every label has to be made by human. once you have several several labels, then we can use program to rotate it to overlap with some other images, to mosaic it, and to resize it to generate hundreds of thousands of different labels. That technique is widely used in the face recognition and the self-driving, the street view recognition. So all the operational deep learning use cases, they all use the label augmentation technique. So so for them, the accuracy of labels is the most important. It's not the number. The number of labels can be increased by program. So we have to ensure that the label is in high quality. So I want to overview to talk about the type of labels. Just as you mentioned, there is 4 types of labels right now, mostly. The first one is you only give the whole picture a label. It means what's in there, some text description of the objects in the picture, no other sense. And that's the first level of labels. It's very simple, but you don't know where the object is in the image. The second one is bounding box. The third one is polygon. So you have to to label the object's position and extent in the image. And the fourth one is the most difficult one to get. That means you have to label the whole picture, pixel to pixel. So that's the most difficult labels we can get. But we can still, the GANs. The GANs is an example. So you want input one image and you want to get another image as output. That's a GAN. So that kind of thing, mostly picture-to-picture model normally do not require human labelers. That's all automatically matched by the program. So what we are talking about here is for the first 3 types of labels, and most existing labeling dataset are the first two types, and the polygon label dataset are very really thin. So currently, the market of the labeling software, it has a lot of options you can choose from. These tools are either developed by the companies or the individuals or open source developers. Some of them are open source. Some of them, the most professional software are commercial licensed, like this Figure 8 and Prodigy. So this Label Me and Label Box, Label IMG are open source, but they only allow you to label the things. They do not manage the labels. If you choose the commercial labeling software, they will manage the labels on their servers, and it will provide a lot of services for you to at least the first manage of them, and then you can discover, you can change, you can add it, and you can invite somebody else to verify the quality of the labels. So that's some kind of data quality control. So everything is done on the website, so you do not have to install anything on your laptop. But for the most open source solutions, you have to install something on your laptop. So that's I think that's one major difference between them. Of course, the open source is free, and the commercial is you have to pay something. In GIS and RIS, GIS and remote sensing domain, I think we have done labeling for many years already. If you consider the supervised classification as one kind of a labeling activity, we have done that for many years. But nobody I think nobody is thinking about using the existing shapefile, vector, OpenStreetMap, or any USGS collected all those vector files as a training data set. If we can do that, then we will save a lot of time and labor to label things, right? We have already used GIS to digitalize a lot of polygons, lines. I think all those things can be used for training machine learning models. And if you're looking for some professional GIS labelers, just go ArcGIS, QGIS. That actually can be used as labels. And the problem with GIS and IIS software is that they are not compatible with deep learning models, because deep learning model developers are not GIS scientists or RS scientists. They are using their own, they have their own tools. They have the whole ecosystem, which GIS is not involved. So they have already developed a lot of labeling tools. And all their models is based on those tools, the labels outputted by these tools. Like the Intel company open source this CVAT microscript. Microsoft have VOTT. All these tools have many years of history. It's not new. The recent solutions like datasets, the Make Sense, the VGG, image annotator. This is developed by the University of Oxford. And this one, I think it's developed by some open source solo, a serious, developer of who is working on deep learning model. This guy, this guy developed this thing is working for Amazon. He developed this one in his free time. So this is an example of labeling tools. So this is label me, I think. So it's like it's labeling clouds. You can see it has many ways to label on the image. It's like bounding box. You can render. You can use this tool. It's like a PS tool to increase the image to outline the boundary of the clouds. This is just one example. Most of the existing solutions have this kind of capability. They all have this thing. So no matter which tool you choose, I think you should cover it. But open source software has some problem about the managing managing these things. So you have to make sure that you understand how to use the results. Okay, so this is what I want to present here. Label IMG is very simple, very lightweight labeling tool. It's only a bounding box labeling tool, so you can only label bounding box using it. It's open source. It's specifically for YOLO. If you know YOLO, YOLO is a very famous neural network for real-time object detection. It's for for example, the traffic camera video. It can every single frame, it takes several milliseconds to process. So it's very fast. It can identify the cars, the people in the camera videos. So this neural network is very useful. So this is its GitHub repository, and installing this tool is very simple. Just one command. If you already have the Python 3 available, then use this command, prp3 install label image. We'll have it installed. This is some steps. So label IMG. You first open some images and then open the directory for saving the labels and create labels. That's it. several shortcuts you might want to use is W means it will turn your cursor to some specific labeling cursor, and then you can label right now. Then Control plus S is save the labels you made. Okay, so the left one is the results, it's the labels. So you can see it has a class name. It shows where this label is stored, and then it shows the bounding box and the location. The coordinates are all image coordinates, so it's not a let and none. If you want to use let and none, you have to prepare some code to transform this image coordinates to the let and none. So normally we create one folder for the input images and one folder for the labels. They have to reside in the same folder. It's better for you to manage, to look for, to search. So the existing label repository like UCI's machine learning repository, most of them they do not provide anything. They just put a zip file on their website so everybody can download it and unzip it and use it. I think they have no searching or something capability for these labels. So for the geospatial image, using the label IMG, you can create all these kind of labels. But one thing about that, the limitation is that it only reads JPEG and PNG. So no GLT for that CDF or HDF. You have to transform that to the JPEG or PNG first. The future vision, I think the requirements of labeling number, labels number will drop because we will create more software to transform the existing labels to many possibilities, to cover many possibilities. So the human labelers will shrink. The requirements for them will be less. And data diversity is significant, is more important than the number of the labels. And we have to, another important thing is that the taxonomy, we have to standardize that. Because one person labeled use this taxonomy and another person use another hierarchy, and their labels cannot merge. So the dataset, the training dataset cannot increase. That's a very huge problem in labeling domain. And another problem is label data should be more fair. It's like you have to find them. If you cannot find them, you will do the same work another time. You are inventing the same wheel. So it's a waste of time and money. So we have to make if the label data is in the public domain, we have to make that more fair. So that's my talk. Thank you.
Yeah, thanks very much. That was very informative, and I'm sort of a newbie to all of this, so if my questions are overly naive, please forgive me. But you were mentioning how existing sort of GIS applications for years have enabled people to label features and imagery. But you mentioned how that's, I think you used the word incompatible. I'm not quite sure if I understood what the point was. Are you saying like if maybe you've done a lot of labeling in your imagery for years and years, but the output of that labeling that you might have done in ArcGIS isn't compatible? Is that what you meant, or did I just totally misunderstand that?
So what I mean is in GIS, labeling is not new, right? So every time we want to classify some image, we have to label something. And those labels are private. After that task, it's probably just keep to that classify scientist. So it's not forming a whole training data set. And that's one problem I think in GIS. If we can find some mechanism to merge those training, the private training data set, I think that's gonna be, be a very big, reusing the existing labeling labels. It's better than creating new ones. So we need to find a way to share those private labels. Yeah, go ahead.
I'm going to repeat your question. So Rahul's point is that data augmentation is helpful, but also the space that the samples cover is an important consideration. You have to make sure that you're actually covering the features in a sort of a realistic manner in your sample set. Is that what you're saying? In the future. So the point is that concepts can drift over time, and just because you've done it at one point in time doesn't mean it will be accurate on future data.
Yeah, that's right. So that's why I mentioned that the data diversity. Diversity is more important, I think, because the data augmenting technique already, it gives us ways to enlarge. If we only have one sample for that space, we will create a lot of possibility, a lot of derived samples for that space. But the bigger space, it's not covered, so we have to make sure each space has at least one sample. Yeah.
Augmentation was referenced in, but I was also interested if there's research going into automatic labeling. So basically bootstrap labeling, if you human label and then the AI is able to find similar images in the training set and attempt to label those, and you iterate. Have you heard of any research like that?
I probably heard several words about it, but I didn't know about the details. Yeah, that's a very promising way, I think. If we can do that, then it will greatly reduce our work.
Yeah, I want to respond to that. I said in my introduction that Arif has been doing some work with automated labeling. I think it's fully automated, but I'm not sure. And then in this, what was the name of the data set that I gave in the introduction, for visual data? That started by using tags and captions as a lift, and then they gave it to people. So I think that there are combinations of approaches that are being done, and I hope we can hear more about those. Oh, yeah.
I'll just say, I think there are active areas of research. It's called semi-supervised learning and reinforcement learning that are looking at these approaches here. So there are active areas of research in semi-supervised learning and reinforcement learning, which are looking at approaches to handle that the question that you were asking.
There are like 8 people on the line. I also saw some stuff from, I'm not sure if it was Google or Amazon, it could be just marketing, but I think they're claiming some of their services that are a lot higher level are actually doing that. So you provide fewer than normal human labeled training examples, and it will do more than just augmentation on that. And I'm interested in more open source research going into that, so that the normal people are able to take advantage of that stuff.
Okay.
Yeah.
Thank you, Shihung. I'd like to move along to make sure that we have time for bokeh. And so, Jim, you're going to help him.
Okay, can you hear me?
Yes.
Great.
We're getting set up for you.
Jimmy can go ahead. You can share your screen now.
Okay, it looks like it's sharing.
Yeah. Excellent.
Okay, does that all look okay and sound okay?
Yes.
Great. All right, well, thank you for accommodating my travel schedule. I'll present something that is in the general area of what's been presented in the earlier stuff was really helpful as context. And then this is a different approach. What we're focusing on is the class of user who's not a deep computer scientist, but is able to work with code, and we're trying to make that person be able to develop custom apps for labeling very easily. So we'll get into that. My current role is at Anaconda Incorporated. We make tools for Python, for scientific usage in Python. Previously, I was a professor, but I'm now in industry. And as part of my job, I'm a manager for a whole bunch of open source projects, primarily in domain of visualization. And we'll talk about some of those projects. And the work that I'm talking about is work that we have undertaken through various contracts and various collaborations with people at NASA Goddard, the Army Corps of Engineers, the Pangeo Initiative, which crosses a lot of institutional boundaries, and sort of informally with USGS. So what I'm actually going to show is actually dive into code. The previous talks showed a running application, and the expectation is that an end user will use that application. And what we're developing is toolkits of things that work, that allow you to make your own applications for whatever your specific purpose is on the fly or very easily without becoming a major computer scientist or a web developer. And so to motivate that, and I'll talk about a set of libraries. They're actually the ones listed up here. Bokeh is the main library that provides the functionality that we'll use here. But we won't use Bokeh's API because that's a low-level API meant for for people like me, people who have been doing computer science for a long time. It's very powerful, but it's also fairly verbose. It's fairly difficult to get started with. And we'll focus on some higher-level libraries that have specific geo support, specific support for projections, and generally making things easier. Just to verify, is everything, I see there were some notes about noise. Is everything all good? Well, I also see there's a note about muting. So let me know if there isn't, break in if there's any problem. Okay, so I'll dive right into it. And let's start with a simple task, which is, let's say we want to find the location of every tree in a state or in a region in order to be able to automatically build a tool that can find trees in satellite images. And you could do this with any sort of data. For convenience, I'm using a publicly available web tile map source. So basically like Google Maps or Google Earth. This particular one comes from Esri, people behind ArcGIS. And in this, we won't focus on the software except, or the code, except to show you that the code involved is not a mess. It's basically we're asking for a set of map tiles. And if you're familiar with Python and Jupyter notebooks, you'll see that this is an interface where you can type a little bit of code and see the output. If you type just a little bit of code, you get a tile server, which allows you to zoom in and will update with high resolution data and so on. So that's our quote unquote data set that we'll use. And then what we want to do is pinpoint the locations of trees. And so here we'll need some sort of object that can collect a set of points. In this case, I've preloaded locations of 3 trees out of all the ones in the world. And here they are in latitude and longitude. These, I'm using a tool called GeoViews. GeoViews on top of Bokeh understands coordinate systems. So it's able to map between latitude and longitude into a different coordinate system for display and back again. So if I take those points and I take that map tile, I can show that in fact if I overlay on top of each other, in this tool, this is the overlay operator. You don't have to worry about that, but it just allows us to show tiles and points together. If you do that, you can see that we've got 3 particular trees out of this neighborhood in Monterey have already been annotated. I did that earlier, basically. Okay, but let's say you actually want to collect, you want to be able to point to all of them and designate each of the trees in this image for later processing. So we already have interactivity. This is provided by Bokeh. That's Bokeh's logo there, so you know you're on a Bokeh plot. And so we can zoom in and zoom out. You can see where we are in the world. If the internet were any good. But let's go ahead and set up something that'll let us do annotations. Here we're doing something called an annotator. This is something we just added to the HoloViews and GeoViews tools. We added the things that it's built on to Bokeh about a year ago, maybe a year and a half. And since then, we've been working to add this higher level interface so that our collaborators at these different institutions can do this sort of work themselves without having to hire us as computer scientists to set this up for them. So in this case, here we have a points annotator. And basically, you can see what that does, which is we still have an interactive image here. You can see that there are 4 points marked. There's a corresponding table that has all of those locations, plus any sort of metadata you might want to associate with it. I don't know, elm. I don't know what kind of tree that is. But let's say we want to start adding more points. We can select this tool, that's point annotator tool, and then we start adding locations of every tree we might want to mark in this image. So that won't take very long. It's not a very big image. And you'll see that each time I add it, we get a new row in this table. And now if we want to select a row, we can see where the corresponding image is. We can edit the row to change the position, although that's probably going to put it off the screen if I do that, but yeah, it did. So I'll select a different one. And we can, if we wanted to put in some numeric value or some, here I defined that there should be a column of integer. Well, it shouldn't have been integer, probably float would have been better. That way I could put a real size. I don't know. And then type here I made to be a string. You can put any sort of different types of information associated with each one of these points. Essentially just collect as many as you want and then add whatever data you want to associate with those points, if any. In this case, you might just want the point, which is you're trying to train a model to find the locations of all the trees. All you need to know is a bunch of long coordinates. And we'll be doing a workshop later today. You can get a hold of the code here and run it yourself and try it all out. So that's what all this text is. It's to explain to you what to do while you're working on it, but I'm ignoring it for now. Okay, so but the main point is not to draw a pretty picture. The whole point is that these tools are designed to let you use web-based tools, web-based interactivity to get data from the user and back into something you can work with. And so now we'll execute this line. This is all the data we just typed in there. Apparently I collect there were 17 dots that I had clicked on, and these are all of their locations. I only filled out the size on one of them, it looks like, and no other information is there. And so you can easily go back and forth between a user interface right here that you created, and then immediately, without saving to a file, without generating some output and then parsing in some other program, you can just be embedded in an environment where you can collect data and immediately do whatever you want to it. So at this point, it's data. It's not a file. It's right there in memory, and it's associated directly with this. So you could transform it. You could feed it directly into the machine learning algorithm. You can do whatever you like. And so hopefully that illustrates the workflow that we're imagining here, which is that you have a user who's maybe not a computer scientist, but is comfortable with Python, who's able to instantiate objects like this tile server. It finally loaded. And configure them, maybe set some parameters, change the columns of data that you might want, to choose that you wanted to work with a set of points, and we'll choose other things later. And then work with the data in Python as if you had read it from a file or as if it had always existed. And so it's trying to make somebody who's in that situation, to give them all sorts of power at very little cost, as opposed to the other types of tools that were shown here, which were dedicated labeling tools that are kind of standalone. They do the one thing, and they do it probably better and faster than any of these tools will. But these can be embedded into a complete workflow where everything is customizable. Everything is up to the user to choose whatever they want to do. If they want to do points at one point, it's great. If not, they can do rectangles and so on. Just to illustrate one more thing, you can also, if you wanted to select a whole bunch of them, either here or in the plot, you can also get those back. So if you wanted to do these, if you want to do semi-custom things, like I wanted to set the size of all the selected ones to the same value, well, that'd be very easy because I have a handle on all of those things. So you can basically work in your browser, build up stuff, edit it, do whatever you like, and then immediately get back into where you're working with data as a program. That particular one was points. There are annotators for these types. Points are a list of points, scatter is a scatter plot, so they're similar. Curves, you could, if you wanted to doctor all your scientific data, you can very easily just, oh, I didn't point out that you can drag these things around. Let's see, I need to select the right tools. Basically, once you've got these visible on your screen, you should be able to select one of them. You should be able to drag it around. I don't know what's going on with that right now. Come back to that. But you can drag the points on a curve. So if you had a measurement, you can doctor it, get rid of outliers if you wanted to. Hopefully use that power for good. Path, that's a connected series of line segments. Polygon is the same as path, but it's filled in. And a rectangle, that's a bounding box. You've already seen examples of that, so I won't spend much time on that. But essentially, it works the same. We initialize a set of bounding boxes. It could be empty, but I always like to have a couple in there so it's clear how it works. And then you create a rectangle annotator. In this case, we overlaid a set of labels on our map so that we can see where we are. And now we can draw a set of new labels here, if I've selected the right one. So you just double click to start and then double click to end that. And you'll see that each time I do that, it's created a new label in a new row in the table. And you can now, if you wanted to, you could be very precise about editing the locations, and it would update. Probably can't see that. Let's see. Yeah. You can edit these directly. You go back and forth between the table and the plotted representation until you've got something you're happy with. And then you go back to Python, and now you've got whatever you created. You just ask for it as a data frame, and then you've got something you can work with, a table. You can save that to disk if you want. You can type it directly to a program. You can cull it. You can run statistics. Essentially, you have it immediately. You do whatever you want with it. And so that was rectangles. You can also do paths and polygons. Those in simple cases that's easy enough to do. You can easily just annotate a shape, and then if you're willing to do all of the work of that in this case is easy because I'm doing it on man-made boundaries. But if I wanted to collect the shape of a natural boundary, you want to combine this tool with things that'll do a first pass that works on the image itself, does some segmentation, gives you a first guess, and then you can use these same tools to edit it once you've got everything. You can then drag the points around. In this case, we can get the data back that we just generated. I think I've got 4 items there. I can choose which of the ones I wanted to get. The last looks like I got this little 3.1 and so on. So again, we can now do whatever we like. And we can keep going back and forth. Once we've got the data, we can save it to disk. Then that can come in to be the initial state later. Instead of defining it hard-coded like this, I could be reading it from a file, doing this, and then exporting it to a file at this point. And then the next time I run it, I'll have all the things I previously annotated, and I can adjust them and move them around or do what I like. So hopefully you get an idea that this is roughly similar functionality to what you've seen in the other tools, but it's much less focused on having being a polished application by itself. It's a way that a user can, without a whole lot of effort, build polished applications that that solve their own particular needs. So if you have a particular type of data, let's say you wanted to be able to draw a polygon and also a bounding box to enclose the region and also put some landmarks of interest, you can very easily do that. That's just applying all of these tools together. Or if you wanted to put extra little buttons around it to label the entire session or to do pretty much anything you wanted, those are all available actually through this separate tool called Panel. This particular thing is built up using Panel. Panel lets you put a plot next to some tables, or next to some text, next to an image, next to whatever, and handles all the coordination and communication between these, all again based on Bokeh. So Bokeh is kind of like the grandfather of all these tools. It has all of the functionality that helps you work in Python, but using data in a web browser. And then we've built these higher level tools that solve specific problems, generally the specific problems that our collaborators care about, and built those on top of it. And so what you do is you use the things I've shown here, and then you build, I have some random things running, like this is an app that was built using a few lines of code, the same kind of tools. This particular one doesn't have any drawing tools. I didn't happen to have that handy, but this all this does is let you choose various things in a menu and update various properties. It's just to show that this is what a standalone app looks like. And what you can do is, having done so, having built up something here using some annotating tool, then you can share this. This particular one is that's a live URL on the internet. So you can make you can build a custom labeler, deploy it on the internet, and just send people this address, and then they can go there. For a labeling case, it would need a button that says "Save my results" or whatever, and then having labeled some things, it would save it, and then it would go into some database. That's all custom code that you would have to write, but it's easily writable. It's easily customizable for whatever your specific application is, and so you can put together the things that we showed here for bounding box, path, and point labeling into applications, share those, collect the data, and then tomorrow you could do something entirely different, a completely different application with a different label, on a different layout and start collecting a different type of data, all using the same tools without having to write a big software program. The total amount of code here is, I mean, this is a few dozen lines. This is a few dozen lines. It's designed to make it be at a high level, something that a more casual programmer, not a deep Python computer scientist, can put together to solve their own specific needs, either for labeling, or actually these, we use these tools. In fact, they were paid for not for labeling, but for simulations. In simulation case, what we did is, let me see an example here. A simulation, we might need to draw a bounding box around, a bounding region around an area that we want to simulate on the Earth at high resolution, and then it would generate a grid to cover that area in a regular grid. You put in little control points to control the density of grid points at that location, and then run the simulation. And so the same tools can be used essentially for anything you might want to do when you're asking a user, hey, you're looking at some data. In this case, it's an image, but it could be a plot of any type. It can be a mesh, it can be a curve. And if you're looking at that data, it collects some semantic information from the user who knows what he's looking at or what she's looking at, and can then turn that back into data, and that goes back into Python. So at this point, I should, last bit, just to tell you how to get started here. First off, you can come to our session later today, after this one, to try some of the tools out yourself. Also, you can, all these tools are described at holoviz.org. They're all open source, Python 2 or 3 compatible as of today. We might turn off Python 2 tomorrow. They're all, just download. This is a big tutorial that covers all sorts of things you might want to do, building the tools up. It doesn't mention annotations because those came into existence this week, but it covers all the rest. And we're using tools, HoloViews, Bokeh, and Data Shader, actually, Panel. Anyway, those are all described at this one site, HoloViz. So if you remember nothing else, go to holoviz.org. And I have one more thing up here to show you, two more. Here's an example of what I talked about earlier, which is that you, in this case, you've created an app where you first ask the user for a bounding box as a rectangle. Then it'll fetch the image associated with the satellite image associated with that bounding box. Then it'll ask the users for some regions, and that's drawing a polygon. And then it uses those regions to automatically, using the grab cut algorithm, to trace the outline of the images and give you something that is a computer-generated first guess at a segmentation. And then you can use the tools to actually grab individual points and move them around if it wasn't a great guess. And so you can have this, this is related to things that we talked about earlier, which is having a mix between human effort and machine effort. Here, if you have some algorithm that's pretty good, you can get a very detailed result from it and save a ton of time for any sort of detailed input you might want to do. And then you present the results to the user, and the user tweaks it, or like in this case, the outline should probably have covered this area, and so on. So the user would edit and move that around, and then come back. In this case, it was going to go back to a simulation. Last thing to mention then is what I had up here to remind me. If you want to learn about any of these tools, whether they come from us or not, HoloViz is all the ones from us. That's from my group, all the people who work with us here at Anaconda. If you go to pyviz.org, you can learn about all of the tools that are available for doing Viz-related things in Python, including Bokeh, but also including all of these other tools, whether they come from us or not. And so it'll help you get started if you want to compare and understand what there is in the Python ecosystem, because the things that I showed today are just a tiny, tiny fraction of what's available for doing geoscience in Python. So at that point, I should open it up for questions while we still have time.
Very cool. wonderful, Jim. What an interesting and powerful tool. I'm going to open it up to questions here. I think you wowed them. Here we go. Hold on.
So the panel construction that we're looking at now, is it possible for it to display multiple images? So if you're looking at multispectral data, you could make enough images to one of the channels?
Yep. That's the key that actually is very hard to demo, because all you can see is what I've specifically done. But what you can't see is that you have almost no limitations on what you might want to do. You can lay out, in this case, what we did is stick a couple of, put some data tiles underneath this. But we could have put other things next to it, other things around it, any number of images. They can all be linked, interlinked with each other. The same data can be overlaid on all of them, so you can compare the same data points against all the different spectral bands, or different satellite dates, imagery dates, or whatever you like. You can put a little slider on here that'll slide through dates. So if you're not sure if the thing you're looking at is a tree, you look at data from another day to see, oh, well, when there's no shadow or no cloud, that is a tree, and so on. And so you can, these are things that are always coming up, and you always find some limitation. And the whole reason that we did this as a toolkit rather than as an application is that that way the end user, or the end quasi-user, somebody who's technical but not a computer scientist necessarily, can make it do what they actually need to do in that particular circumstance. So yeah, it doesn't care whether these are spectral. In fact, the annotator doesn't even know there's going to be an image here. It only knows about the points, because that's all it has to deal with. We just kind of stuck the tiles underneath it, but it would work the same if we took the tiles out. If we just had the tiles alone, I mean the data alone, we can work with it just the same. The tiles are just for the human use here, and you can put anything you want in any combination of those there.
Very powerful. Oh, here we go.
Great talk, and really looking forward to using some of these annotation tools. Quick question, is Bokeh still under active development, and is that under Anaconda?
That's a very good question. Yes, it's yes and sort of no. The Anaconda developed Bokeh starting in 2012, and the lead author of Bokeh, he actually currently, that's Brian Vandeven, he currently works for Microsoft. And so in that sense, the development of Bokeh is outside of Anaconda. And then in another sense, it's outside of Anaconda as well, because Bokeh is led by a steering committee or steering council, and that has people from Anaconda and Microsoft and other companies who actually control the direction of the project. Here at Anaconda, we contribute a lot to Bokeh, and we pay one of the main Bokeh developers half-time to work on our stuff and half-time to work on whatever Bokeh needs. So our stuff means whatever our collaborators are asking for, and then the other half is whatever the world is asking for, unpaid. And so there's support for it, but it's no longer controlled by Anaconda. It previously was.
Right. We're a little over time. I'm not seeing anybody jumping up right now for a question. So I want to thank all of our speakers for some really wonderful content today. I think this is really great. I thought we finished at, and we start the next session at, I was thinking it was 12. Oh, it's only a 15-minute break this time. Ah, okay. Oh, well, let me just see if anybody has any final comments or thoughts. I had thought that in this session, if we had a few minutes left over, we might have some kind of a discussion comparing and contrasting these tools. I don't know if there's any thing on anyone's mind about that. I'll just wait a moment. or anything anybody would like to bring up about labeling in general or anything? Okay, I guess
I'd
we'll.
like to bring up one thing if I can,
Yes.
which is that these tools, like I mentioned at the beginning, are brand new. And what that means is if somebody's going to get into some very large project, almost certainly you're going to get into it and find out, oh, you know, when I'm doing this 100 times, what wasn't annoying for the first 100 is now being annoying for the next 1,000. So we would really appreciate feedback like that. Basically, the tools work, we use them, and they're great for what we've done. If you try them in something where they don't work, that's feedback we'd really like to have at this point, because that's what's going to make things be polished and easy to use for real people in real world situations.
All right. I think we're good for now. And again, I want to, can we just give our speakers a round of applause for some really great work and some really great content? I learned a lot today, so thank you all very much. And we will reconvene at noon with our workshop. And thank you so much, Jim, for putting on in all this effort and being online. And I know we're going to get more good stuff in the next session. So, okay. Thank you all.
Thank you for organizing. It's great.